Alright, this is lesson 2.2. We're going to talk about points, lines, and planes some more and introduce some new things in those avenues. First couple things are review. A point is an exact location in space with an indefinite size or shape that's represented by a dot. Again, a point gives you a location. It does not have any size or dimension to it at all, and it could be named by a capital letter. So how do you name it? You just name it with a capital letter. So if they say X, that's point X. A line is an object with no thickness that extends infinitely in two directions. So we put arrows on both sides to show that it goes infinitely in both directions. And you need 2 points to name a line. So if this point is X and this point is Y, those are 2 points on the line. I can name the line with those 2 points. Remember, when you name a line, you always have to put the line symbol over the top. It's not a line symbol unless it has 2 arrows. Now remember, when you name a line, order of the letters doesn't matter. So if you want to call it line YX, that's perfectly fine. Now there was one more way to name a line, but this is the primary way, so I'm not going to review the other one right now. Okay, something new today is a line segment. A line segment is part of a line that consists of 2 points called endpoints and all the points between. So a line goes to infinity in both directions, so it's infinitely long. You can't measure the length of a line because it has no beginning and end. It has no stopping points. It keeps going forever. It's infinitely long. A line segment is part of a line, and it has 2 endpoints. So you can actually measure a line segment with a ruler or a tape measure or whatever. If I were to take X and Y and use those as endpoints, it would include X and Y and all the points in between. That right there is a line segment. It's part of a line, not the whole thing. A line segment does not go to infinity in both directions. It goes from one endpoint to another endpoint. So this is an example of a line segment. If you can measure it with a ruler or a tape measure, it's a line segment, not a line. Lines are infinitely long. Segments are finite. You can measure those. Now when you name a segment, it's the same basic thing as a line. You're going to use the 2 points. Now on a line, you can use any 2 points, and it doesn't matter which ones. With a segment, you've got to use the end points. So if there was another point right here in the middle, I wouldn't want to use that one. I need to use the endpoints. Now with a line segment does not have any arrows on it. So this is the symbol for line segment. You do not need to put dots or points on the ends. Just do not include the arrows. Now just like a line, the order doesn't matter. So I can call this line segment YX as well. So when I read this as line XY. When I read this as line segment XY. We've got to understand the language of geometry. We're learning to read what is written and understand what they mean, and we're learning to write what it is that we're wanting to communicate. So this communicates line XY, this communicates line segment XY. Okay, the next thing we're going to learn about is array, and it's also part of a line. It consists of one endpoint and extends infinitely in one direction. Okay, so it's got one endpoint and extends infinitely in one direction. So if I go back up to this line again, I could cover up this extension to infinity, and this would be array. Or I can cover up this extension to infinity, and this would be array. Array extends to infinity in only one direction, so it has one endpoint and one arrow. Now when you name array, this is the first time that the order of the letters is important. Array does have a direction because it only extends to infinity in one direction. So it always starts from the endpoint and goes through another point as it goes towards infinity. And we put a array symbol over the top, so there's one arrow. The arrow always goes on the right hand side of the symbol, never the other way. It doesn't matter which direction the ray is pointing in the picture. The ray symbol, when you're naming the ray, always points from left to right. And again, order does matter. So this is the only way you can name this ray. We can't name this ray XY. Ray XY would start at X and go to infinity through Y. That would be a different ray. It would go this direction. For this ray, it's got to be named ray YX. Alright, opposite rays are two rays that share the same endpoint but extend infinitely in opposite directions. So if I have ray XY, and then I have another ray that starts from the same endpoint but extends to infinity in the opposite direction, those would be opposite rays. Ray XY and ray XZ. Notice together they form a line. Because a line goes to infinity in both directions, rays extend to infinity in only one, but if you put two of them together and they're going the opposite ways, together they would create a straight line. But these are opposite rays, ray XY and ray XZ. And again, order is important. So we got ray XY and ray XZ. Those two rays are opposite rays. They share the same endpoint, extend to infinity in opposite directions. Okay, with all that information, let's look at example 1 down here. We have a picture of information, and we want to write down 5 things that we know about this picture. Now, I'm doing this for you in class. I would ask y'all to give me things. There's not exactly 5 things. There are tons of different things you could give me in this situation. So I'm just going to give you 5 of them. 1, we just talked about opposite rays. Do you see any opposite rays in the picture? We got ray BC and ray BA are opposite rays. Okay. Something we talked about last time was collinear and coplanar. How about some collinear points? Points that are on the same line. A, B, and C are all on the same line, right? So A, B, and C, those 3 points, are collinear. Okay, we just used collinear. What about coplanar? Coplanar are points that are on the same plane. Well, on this plane, I see points X, B, and Y. So I know that X, B, and Y are coplanar. What's another name for that same plane that those points are on? X, B, and Y create this plane right here. What's another name for that plane? Plane R. Alright, what about the plane we're looking at and the line that's intersecting it? Where are they intersecting at? If you have a plane and a line intersects it, and that line's not on the plane or parallel to that plane, it's going to intersect it at one point. So, plane R and line AC intersect at what? Think about taking a piece of paper and shoving a pencil down through it. Where's the point where it intersects? Right here. Point B is where that pencil is going to break through the paper to go down through the paper. So it's intersecting the plane at point B. So plane R and line AC intersect at point B. So those are 5 things I can get from this picture. And again, those are not the only 5 things. You can come up with other possibilities. Alright, when we're doing these questions on this page, most of them are going to ask why or why not. Most of them are going to ask you to explain. And it all goes back to the postulates and theorems that we learned. Okay? First thing it is, are points S, O, and M coplanar? I'll give you a hint. I don't even have to look at the picture to answer this question. Because we learned that if you have 3 points, you always have at least one plane that can go through them. So the answer to this question is yes. Any 3 points create at least one plane. Remember, if the 3 points are collinear, then there will be an infinite number of planes that go through there. If the 3 points are non-collinear, then there'll be exactly one plane that goes through them. And if I take the time to look at the picture, S, O, and M, they're not collinear, so there's going to be exactly one plane that goes through them. The tricky part when you look at the picture is you got a picture of a box or a rectangular prism here. You got a top, a bottom, front, back, left, and right sides. S, O, and M are not on any of the planes that are drawn for us. They're not on any of the faces of that box. But that doesn't matter. There is a plane that exists, even if it has not been drawn, that contains S, O, and M. Okay? How many planes are shown? Now here's the key right here. I just talked about a plane that exists through S, O, and M, but it's not drawn in the picture. This asks how many planes are shown. Well, we had the top, the bottom, the front, the back, the left, and the right. So that is 6 planes that are shown in the picture. That doesn't mean there couldn't possibly be more, but there's 6 that have been shown to us, already drawn in the picture for us. Alright, name the intersection of planes LON and PQM. And I'm going to shade the picture for you so you can kind of see this a little easier. Plane LON. L, O, and N are all on the top of this box. And so when it says plane LON, they're talking about this plane right here. And then plane PQM. PQM. PQ and M are all on this front face. So they're talking about this plane right here. So the question is, what is the intersection of those 2 planes? And hopefully you can see that these 2 planes are intersecting across this line. They are sharing that line. This line is on this plane, and that line is also part of this plane. So that is their intersection. So we need to name this line. Remember, we learned that 2 planes always intersect at a line. The name of this line, when you name a line, you need 2 points. And you always put the line symbol over the top. Make sure it has 2 arrows. And our explanation is that 2 planes intersect at a line. Alright, name the intersection of plane MQR and line ON. So here we got plane MQR. So that's this right side, or this right face. MQR is this plane. And we got line ON. Here's line ON. So where is this plane and this line intersecting? They're intersecting at point N. So that's the intersection of plane MQR and line ON. And it says explain a plane and a line intersect at a point. A line can be parallel to lines on a plane and then it never intersects it. A line can be on a plane where all the points of the line are on the plane. But those are the only 2 cases where a plane and a line don't intersect at one point. They either don't intersect at all, they're intersecting at all their points because the whole line is on the plane, or every other circumstance is that the line will intersect the plane at exactly one point. Alright, do S and M determine a line? Why or why not? Now this is another example of something where the picture can be confusing, but I can answer this without ever looking at the picture. S and M. I don't see a line drawn through them. But just because it has not been drawn there does not mean that it doesn't exist. Remember, we learned earlier that 2 points always create a line. We learned that there is always exactly one line that can go through 2 points. So, do S and M determine a line? Yes, they determine a line. Through any 2 points, there is exactly one line. How many lines are there through points N and Q? Well, let's use what we just finished writing down. What did we just write? Through any 2 points, there's exactly one line. So how many lines are there through these 2 points? There's going to be exactly one line. Okay, there's always going to be one line. And you can rewrite all this if you want to, but take all of this and put it down here as well. Ditto. Use that same explanation for that problem. Number 7, how many planes are there through points S, T, and R? Again, I don't need to look at the picture too much. There's only 2 options. I do need to check the picture for this. Remember, if the 3 points are collinear, if they're all in a straight line, then there'll be an infinite number of planes that go through those points. If the 3 points are non-collinear, then there'll be exactly one plane. So I just need to check and see if they're collinear. So look up here. Here's S, T, and R. Those 3 points are collinear. There will be an infinite number of planes that go through those 3 points. Again, that can be confusing for some people because if we look in the picture, only 2 of those planes have been drawn. This plane right here is intersecting those 3 points, and this plane right here is intersecting those 3 points. But think about this as just like an axis, and you can just rotate planes around that thing and create a new plane. You rotate it just a little bit, there's a new plane. Rotate a little bit more, there's another plane. So when we write our explanation, through 3 collinear points, there is an infinite number of planes. Sorry, I'm a little off the screen there. Through 3 collinear points, there is an infinite number of planes. All right, the next thing, we want to name the intersection of line PS and line OS. So here is line PS, and here is line OS. Where are those intersecting? They're intersecting at point S. Two lines intersect at a point. If 2 lines are going to intersect, they always intersect at one point. They can be parallel lines and never intersect, but if 2 lines intersect, if they're not parallel, they're going to intersect, and when they intersect, it's always at a point. 2 lines intersect at a point. And you'll notice, even looking at the names of the lines, and this doesn't always work, but they're sharing a point. That shared point is where they intersect. How many planes contain line LO and line OS? So we're looking for planes that have both of those lines on them. So let's look over the picture. Line LO and line OS. So here's line LO and here's line OS. How many planes contain both of those lines? If I look at this back plane, it contains OS, but it's not containing LO. If I look at the top plane, it's got line LO in it, but it doesn't have all of line OS in it. It's got the O, but not all the rest of these points down to S. But on this left side over here, this face right here has both of those lines on it. So let's name that plane. Now remember, when you name a plane, you need 3 points. We have 4 points. So you pick any 3 of those 4 And you can put them in any order you want. I'm just going to say plain LOS, but that's not the only way to name it. Oh, it says how many planes. Oh, I'm sorry. That's the name of the plane. But that is the only one. So the answer here, how many planes, is just one. One plane. Sorry about that. Now we want an explanation. If two lines intersect, there is exactly one plane that contains both lines. So anytime you're talking about two lines that intersect, there will always be only one plane, and there will be exactly one plane that contains both of those lines every time. Last one, guys. Is line OM in plane LMN? Now, for line OM to be in plane LMN, every single point on that line has to be in this plane. Not just some of it. All of it needs to be on there. So let's look at plane LMN. LMN, that's this top plane up here, the one that's in red. Is line OM in the plane? OM. Now notice, the line has not been drawn yet. But is O on the plane? Yes. Is M on the plane? Yes. Then the line containing those 2 points will also be on the plane. Notice how every other point on this line is still a part of that same plane. So your answer is yes, and we had postular theorem earlier that told us this. It said if 2 points are in a plane, so we figured out that O and M were both in the plane, so 2 points are in the plane, then the line that contains the points so that would be line OM, contains O and M, that line is also in the plane.